Now we want to move on to talking about coming up with formulas for ionic compounds that contain the polyatomics. So say we want, what is the formula of an ionic compound formed between ammonium and sulfide? So sulfide, we know, is S2 minus. Ammonium is then that NH4 plus cation. So if we're going to be going about forming, again, we're still dealing with an ionic compound, we can think about this in the same way. We can still use the same crossover method where we take those charges. We know we move them over, right? The +1 on the ammonium goes to the sulfur, and the 2 on the sulfide goes to the ammonium. And so we move them over. The difference is that when we have that 2, what that means is we really have 2 ammoniums, right? The ammoniums aren't changing. We're not changing what they look like. And so we use these parentheses. So what this parentheses is implying is you'll see the 2 is on the outside. So the 2 is affecting that entire ammonium. You have 2 of the NH4. So you have like NH4, NH4, and S. There are 2 whole ammonium ions for each one sulfide ion. You don't distribute it in, you don't simplify anything like that. You just keep the 2 out there. And so you leave it out like that. You don't always need parentheses when dealing with polyatomics. If there's ever parentheses in a formula, that means you're dealing with polyatomics. You don't always need parentheses when you're working through this. So for example, ammonium and chloride, that'd be NH4 plus and Cl minus. Those both have charges of 1. It's +1 and -1. So when you do the swapping, the 1 and 1, it's just NH4Cl, right? You don't have a parentheses with a 1 on the outside because you wouldn't write the 1 because we never write those. So then you don't need the parentheses. So one of the implications of that is when you see, something like this, it's really clear that you're dealing with ammonium. But here we have to be a little more eagle-eyed. We have to be a little more careful to see that that is ammonium in the compound. So we want to be careful to parse that out. That's why one of the things we want to, this is kind of hidden when it's written in the formula. It's not quite so obvious that it is a polyatomic. We could also have a situation, say ammonium and nitrate, NH4 plus, NO3 minus. When we do that, now it's NH4, NO3. Neither requires parentheses because we have 1 of each. They're both polyatomics, but this would be the correct formula because we keep the polyatomic together. We are not changing what the ions are when they form a compound. So this N stays right here. This N stays right here. That is the correct formula. We don't combine them together to be like N2 or something like that. We leave it as NH4 and NO3. NH4 and NO3. Again, we really want to be careful that that these are polyatomics, pulling them out kind of in the wild when they're deployed. Another thing to note, if you have 2 atoms of the same type that are not together, that's also a good sign you're dealing with polyatomics. You got nitrogen in these 2 different ions. It hasn't been combined. And so this idea of using parentheses is really implying that you have 2 of them. So for example, the CaOH2. That 2 means that you have one OH, that's a hydroxide, and a second OH that is a different hydroxide. They are different ions that are together. And the idea is, you have the 2 plus on the calcium, and then you have the 1 minus and the 1 minus. So those combine to make it 0 overall, to make it neutral overall. You need 2 of those calciums for it to work. And so we can see how that works out. We don't need parentheses when we have, say, 1 plus 1 and 1 minus 1, NH4CN, ammonium and cyanide. Those are still polyatomics. There's the 2 of them that are separate, but you don't need a parentheses on either of them because there's 1 of each. All right, let's look at some examples of writing molecular formulas for compounds between these ions. So I have magnesium and sulfate. And so even though I'm looking at polyatomics, I'm still going to use the same crossover method. So write the charge of the cation, write the charge of the anion, and then simplify. So if I start with magnesium and sulfate, magnesium is +2 and sulfate is -2. When we move them over, right, if I move them over, I'd get the 2 and the 2. But what ends up happening is those two cancel out, right? Those would simplify. You have 2 and 2. They cancel out to be the same. They're both just 1 and 1. And so you, again, don't need parentheses. Ammonium and sulfate, here I have the 1 move over and the 2 move over. And so in that case, the 2 is in front, I have 2 of the ammoniums. Because it's a polyatomic, that 2 needs to be outside parentheses. Sulfate does not need parentheses because it is a polyatomic. Aluminum, we saw earlier, that's the 3+, and sulfate, again, we do our switcheroo. The 3 moves over here, is now on the sulfate, and the 2 goes to the aluminum. Because there's a 3 on the sulfate, now that goes inside parentheses. Okay. So we can see that the polyatomics, they work in the same way, just the added complication that if you have more than one of the polyatomic, it gets a parentheses around it with that number on the outside. One of the things you can also hopefully see is that, as we start to work with these polyatomics, they get a bit more complicated, right? We're kind of doing stuff with them beyond just memorization, just knowing what they are. And so that's why it's going to be really useful to learn what they are. Sulfate as SO4 2- is a very commonly used polyatomic. It's really useful. So it comes up a lot. It's very common. And so knowing that it's sulfate, when you see that word sulfate is SO4 2-, makes it easier to move forward because you're not having to think about what that is or look it up. And you can focus instead on forming the compounds and remembering all of those rules associated with ions in general and polyatomics in particular. Participation 6.5, question 2. What is the formula for the ionic compound formed between calcium and nitrate? This is the second question on participation 6.5, due Friday, June 5th at 11:59 p.m. over on Blackboard. Link to the assignment is right below links to these videos. Again, what is the formula for the ionic compound formed between calcium and nitrate? Okay, another question for participation 6.5. Second one. A couple more videos to go. See you in the next one.